Hey everybody. In class today, we didn't get a chance to get to our third sample problem with the kinematics equations. And so I thought I'd go ahead and record a little video to go ahead and do this so we can fit it all in. This problem is a two-step problem, and you'll see what I mean by that in just a moment. So I'm going to start doing our solution in the exact same way that we did it in class, by beginning this whole thing by determining the direction kind of positivity, which direction is going to be positive. So this one says a car traveling in a straight road at 15 meters per second accelerates uniformly to a speed of 21 meters per second in 12 seconds. Find the total distance traveled by the car in this 12-second interval. So I'm going to go ahead and assume that to the right is positive, which means that these velocities here are kind of to the right. So let's put them in those categories. And I'm going to create my table here. So my starting velocity and my ending velocity, my change in position, which doesn't look like a very good delta, so let's redo that. Change in position, my acceleration in the x direction, and the amount of time. So there's the things that I need to know and can solve for. Let's plug in the things that I already have up in the problem up above. This 15 meters per second, that's my starting velocity. This 21 meters per second is my ending velocity. 21 meters per second. My change in position, I don't actually know what that is. My acceleration, I don't know what that is either, but my time here is 12 seconds. So I'm going to put in my 12 seconds. So what am I solving for in the end? What I'm solving for is the amount of distances actually has traveled along its way. But I actually have two unknowns, and you'll notice that one of my unknowns is my acceleration here. If I look over at my kinematics equations, all three of these kinematics equations actually have acceleration in them, which means if I don't know my acceleration and I also don't know my change in position, I'm going to end up with a problem that has two unknowns in it. So a single equation and two unknowns, and that's not solvable. So what I need to do first is I need to solve for my acceleration to begin the process. So I'm going to go ahead and use this first equation right here in order to be able to solve for my acceleration because I know everything else. So I have this Vx plus V, equals, try it equals, there it is, Vx0 plus AXT. And this is a point where many students would say, oh, I'm going to start plugging in numbers there. But I'm going to say hold off and let's solve for acceleration first, and then we'll plug in numbers afterwards. So to solve for acceleration, I need to get this initial velocity to the other side. I also need to give my time to the other side. So if I move this over to the other side and I move my time over, I end up with Vx minus Vx naught all over t. It's a little quick algebra there. But now what I've got, I can start plugging in my numbers now at this point, and that'll work out just fine. So my ending velocity is 21.0 meters per second minus my starting velocity, which is 15.0 meters per second. And then my time is 12 seconds. Right? And that's all going to equal my acceleration, right? And in the end, I can go ahead and solve this. I don't even need a calculator to solve this because I've got 21 minus 15 is 6. 6.0 if we're following significant figures here, so 6.0. You'll notice that we've lost a significant figure on this one when I did the subtraction. So now I went from 3 down to 2, and underneath I've got 12.0, so I've got 12.0 seconds. And when I do my final kind of acceleration calculation here, I've got two significant figures on top, 3 on the bottom, and so we end up with 0.50 meters per second squared. So I'm now down to two significant figures. So now I've got a problem that was unknown before, but now it's known. So I can plug that in as 0.50 meters per second squared. And at this point, I know everything except for my change in position. And if I look over here in my equations, I can actually use both 2 or 3 to be able to get there. I'm going to go ahead and use the second one in order to get there this time, because why not? It doesn't quite have as many squares in it. We'll see if it makes it easier. So I've got an x here equals x naught plus vx0t plus a 1/2 ax t squared. So I've now just copied that over. If I bring this x naught to the other side right away, then that's actually what I'm solving for, which is an x minus x naught, which is my my change in position. So I'm going to go ahead and do that right now. So I'm going to say a change in position. Please ignore my beeping dishwasher over there. Apparently it's done. So this is change in position is equal to a starting velocity times my time plus 1/2 my acceleration in the x direction times my time squared. And what's going to happen is that this vx naught times t, this is if my initial velocity was unchanging, that's how far I would travel just as is. So I'm going to start plugging things in because it's already solved for my change in x. So my initial velocity, if you remember, was 15 meters per second, and my time is 12 seconds. Oops, 12.0, right? And again, this would be what I would get if there was no acceleration whatsoever. So this is my position that would happen if I wasn't accelerating. But I am accelerating, so I get to add on a little extra. So plus 1/2 times my 0.50 meters per second squared times my time, which is 12 seconds quantity squared. All right, so this first part, 15 times 12 meters per second times seconds, the seconds are going to cancel out here, and I'm going to be left with meters. And so I end up with 180 meters. 3 significant figures on that one. And then I'm going to add on to it. If you look over here, I've got 1/2 times 0.5 times 12 squared. So if 12 squared is 144, 1/2 times 0.5 is 0.25, so 144 times 0.25. And I'm going to walk away from this with only 2 significant figures, which is 36 now, and meters per second squared times second squared. So I'm just going to get meters in the end because my second squareds are going to cancel here. And if I add these two things together, I've got 2 numbers. Now, check this out. I've got 3 significant figures and 2 significant figures here. But my reality is that when I do addition, I'm not actually going to lose anything. So 180 plus 36 should be 216 meters. And that's what I walk away with my final answer for the amount of distance that I have covered. Based on the fact that I started 15 meters per second, I ended 21 meters per second, and I do that for 12 seconds overall. So that's the problem, and hopefully that made sense. If you have any questions, you're always welcome to come in and talk to me. All right, take care, everybody. We'll see you next time. Adios.